expressions. And so in order to do this, we have to start with the concept known as the LCM. Does anybody remember what the LCM stands for? Least common multiple. And so what we're going to do is we're going to find the least common multiple between 6xy, 15x squared, and 9xy to the fourth. And so the first way to do this is we're going to break this down and look at the individual components in order to find the least common multiple. Okay? And so what I'm going to go ahead and do is I'm just going to take the coefficients, 6, 15, and 9. And I need to find the least common multiple of those. If that doesn't come to you easily, here is a way that you can do that in order to find the least common multiple. Okay? Notice how I've written the numbers, 6, 15, and 9 in that line. What you're going to do now is you're going to think of those numbers. What will divide all three of those numbers, 6, 15, and 9? 3. 3 goes into all three, right? And then that leaves me with 2, 5, and 3. Now, in looking at that, is there anything that will divide 2, 5, and 3? No. Is there anything that will just divide 2 of them? Like, is there anything that will divide 2 and 5? 5 and 3? No, so that's where you stop. Now, when I think of LCM, I notice it's got an L in there, right? So what I'm going to do now is create an L. And I'm going to outline those numbers I've written in blue. That is what the LCM of those three numbers will be if you multiply all those together. So if I multiply 3 by 2 by 5 by 3, I get what? What? 90. So that is part of my LCM. So that is just the numerical part. Now what I'm going to do is I'm going to look at the variables. Now in order to find the LCM of the variables, it's just going to be whatever the highest power is. So the first variable I have is x. I have an x here, an x squared, and an x. What's the highest power? X squared. So that's the LCM of those. Okay. And then I have a y, nothing, and a y to the fourth. What's the highest power? Y to the fourth. So that is the LCM. Okay, it's whatever the highest power of the variable is. All right, now where we're going to use things like the LCM is we're going to use things like the LCM in the denominator for when we add fractions. And so let's go ahead and look at another problem. 12a squared b, 15abc, and 8b cubed c to the fourth. So the very first thing I'm going to do is I'm going to look at the numbers 12, 15, and 8. And if I can't readily think of what the LCM of those three numbers would be, that's when I start writing them down. Okay? What will divide 12, 15, and 8? There's nothing, but well, is there something that will divide like 12 and 15? 3. 3 goes into 12 and 15 how many times? 4 and 5. Does it go into 8? No, so we're going to leave the 8 alone. Okay, is there anything else that will divide something? 4 and 8, what will divide 4 and 8? 2. So 2 goes into 4, 5, 4 times. Okay, is there anything else? 2 goes into the 2 and 4 again. So I really could have taken a 4 out, but that's okay. So I have 1, 5, and 2. So now we're trying to find the LCM, so I'm going to go ahead and create an L now. I'm going to take these numbers right here, and I'm going to multiply those. And what do I get when I multiply those? What? Not 120, close. Yeah, 120. Yep, good call. Sorry, I was thinking 180, but it's 120. There you go. Okay, so then now that is my LCM of the numbers. And what I'm going to look at is I'm going to now look at variables. So I've got a squared, a, and nothing. So what's my power of a? A squared. Very good. Okay, b cubed. So the power is b cubed. And then the last one will be c to the fourth. So that is my LCM. Questions? Think you can handle that? Pretty straightforward. So, oops, sorry, skipped one. Let's go ahead and look at this one. We're still finding the LCM here. Y to the fourth plus 8y cubed plus 15y squared. And then y squared minus 3y minus 40. Now this is different than the problems we've looked at. And how is it different? It's like, yeah, it's like in an expression form. It's not just one single term. It's multiple terms, and they're separated by addition and subtraction signs. And so what do you think I could do with this term right here? What's the very first thing you think you can do? Take out a 2y's. Yeah, so let's take out a y squared. And then what does that leave me with? Yep. Yep. Okay, so now if I look at anything here, do I see anything else that I could do? Factor, good. And what will that factor to be? Y plus, what'd you say? 5, yep, good. Good. So 2 factors of 15 that add to 8. 5 and 3, very good. So now what I've done is I factor that first. Now what I'm going to do is look at the second. I'm going to look at this one. What can you do there? Just factor. What does it come out to be when you just factor? Y minus 8, very good. Good. So now if you remember in all the other problems before, if there was something in common, okay, we took it out, right? Okay. So if there's something in common, the y plus 5 is already there. And so in this case, the LCM in this case would be, so if I would take out the y plus 5, so let's just imagine I have my y squared here, y plus 5, y plus 3. Remember how we would line this up, and then we would go y minus 8, and then y plus 5. So then now what you would do, I wrote those up too high, so I'm going to do that. What we would do now is we would do the L, and then we would take out the y plus 5. In which case, when I take out the y plus 5, what does that leave me with here? Y squared times y plus 3. What does that leave me with here? Y minus 8. So really, what the LCM is in this case is the LCM is this whole conglomerate. So in this case, it's y squared times y plus 5 times y plus 3 times y minus 8. Now say, for example, you don't want to write out that green stuff. Is there a way that you could visibly look at the two quantities here and determine what the LCM is? And the answer is yes, you could. Okay? This is the thing. Basically, you have to include everything. Okay? And if something occurs twice, you just put it once. So when I say something occurs twice, notice the y plus 5's occurred in both places, right? So I'm only going to write one of them down since it's in common. I'm not going to write both of them down. Okay, and we show kind of how that is. Does that make sense? All right, let's look at this one, because this is along the same lines. 4x squared minus 12x minus 16, and x cubed minus 9x squared plus 20x. So what am I going to start by doing? Divide by 4 on that first one. Now, when I divide by 4, I'm going to factor that 4 out. So that's going to leave me with x squared minus 3x minus 4. What do I get now?
4 times x minus 4x plus 4.
Okay. All right, let's look at the next one. What do you get from the next one? Take an x out. You get x squared minus 9x plus 20. What do you do now? Yep, x times x minus 5 times x minus 4. Okay, so now let's go ahead and look at what we have. I have a 4, so that's part of the LCM. What else is part of the LCM? X. For some reason, the pen's having trouble. There we go. X. What else is part of the LCM? X minus 4. What else is part of the LCM? X plus 1. What else is part of the LCM? X minus 5. Why didn't I use 2 of the X minus 4s? Because there's both of them in here. So since there's 2 of them here, I'm having trouble with that pen. Okay, since there's 2 of them there, I'm only going to use 1 of them in my answer. So that is my final answer. Wow. I was having a little trouble with it. Questions? All right, so this is where we're going. Okay, simplified. 3y over 2x cubed, okay, plus 5z over 8x squared y. So now in order to add fractions, you have to have common denominators. And so I have 2 denominators here, okay, these 2, and I need to find out what the least common multiple is between those 2 denominators. So the easiest way to start is to look at the numbers. I have 2 and 8, right? What's the least common multiple between 2 and 8? Least common multiple. What is the biggest number that both of those go into? 8. Okay. All right. What's going to be now my least common multiple with x cubed and x? X cubed. And then what else? Y squared. So that is what my new denominator is going to be. That is what my new denominator is going to be from both of those. And so I need to somehow create 2 fractions that have those as the denominators. And so now I need to look. 2 times what is 8? 4. So that means I need to multiply this up here by a 4. What else do I need to multiply that up there by? What'd you say? Just a y. Okay, because the denominator now needs a 4, it needs a y, so whatever you multiply the bottom by, you also have to multiply the top by.
Is that y on the bottom of the scale?
Oh, y squared. Oh, I'm sorry. Yeah, you're right. Y squared. So that's why you were saying y squared. Yep, I'm sorry. I was mistaken and I thought it was just 1y. You're right. And so y squared. And so now up on top, when I take 3y times 4y squared, what does that give me? 12y cubed. Very good. So let's look at the second term. I need to make 8x cubed y squared. So what do I need? I need to make that 8x cubed y to the squared here. So what do I need to add here? An x what? An x squared. Why is it only squared? You only need 2 more x's because you already have 1 to start with, right? You already have 1 here in the denominator, so by adding 2 more, you've made your x cubed. So if I have 5z times x squared, what am I left with? 5x squared z. Now, in order to add those 2, you have to have common denominators, which I do have. So now all I'm going to do is combine the numerators. So on the top, I'm going to have 12y cubed plus 5x squared z all over 8x cubed y squared. There you go. Okay, we're going to go ahead and look at another one. All right, call that good for today. Okay, so here we go. (3a squared over 16b squared minus 8x over 5a cubed b). So go ahead and find the least common multiple of the 2 denominators. Okay, so you start with the 16 and 5, and remember, if you can't find the LCM with 16 and 5, the way to do that is to just take, remember how we did that with the L? Is there a number that'll divide both 16 and 5? No. So then as a result, Here's your LCM, 16 times 5, which is what? 80. Okay, what's your power of A gonna be? A cubed. What's your power of B gonna be? B squared. So now in my first term, I need to make that 80A cubed B squared. So I already have a 16. So what do I gotta multiply by in order to get 80? 5. I have a B squared, but what do I need to add? A cubed. So remember, I've got to do that on both the top and the bottom. So the bottom becomes 80A cubed B squared. What does the top become? Good. Now, what do I have to multiply the next one by? So I have 8 times 16, which is what? 128 bx xb over 80 a cubed b squared. So what will my final answer be? Yep. Minus 128. Good. All right. What we're going to do is we're going to call it good for today, and we'll continue with this Monday. Okay, I'm going to go ahead and give you your assignment, though, so that you can start, because eventually what we're doing is we're looking at going to multiple ones like this, okay, with 3 terms. So here you go. I need you to go on page 541, 18 through 27. Okay, 541, 18 through 27.